So I've just expanded um, this observation that we just discussed on a 2D grid way. So here I have in the rows I have got all the characters A E I O and U, right? These are my rows, and now in the columns I have got n is equal to 1 and n is equal to 2, for example. So for n is equal to 1, we have already seen that if the character is only because we have only got one character, right? And so for A, it would be only one string possible, A, E, I, O, and U. So this is all one. This is our base condition. So for n is equal to 2, right? We have to see that how many times for n is equal to 2 here, we have got strings ending with A, right? Because as we did discuss that for n is equal to 3 and for higher cases, it all depends on what is the last character. And based on that, we create the new strings of the particular length given uh, based on the rules for the last character only. So let's see for n is equal to 2, there are how many strings here which ends with A, right? So let's count it down first. So let me actually use this. So we see that A ends here. Similarly, A ends here. And A ends here, right? So it means that the total strings that ends with A are 3. Similarly for E, if you notice, so let me, for E, we have got this one string and this one string, right? These are the two strings in all the possible strings possible for n is equal to 2. There are 2 total. Now, but like just writing this formula, it's like we are just calculating it in the very intuitive way. But actually, we have to see that if there is any pattern or any algorithm that we can use instead of just searching for all the strings ending with E, just we have just done. So let's see again. How do we get this number 3? If there is any formula we can deduce from here. So we found that how many strings are ending with A, right? But let's revise the rule again. That which are the rules which says that a particular character or a vowel can be followed by A. So here we see that in this rule, each vowel E may only be followed by an A. So we have got one case here where if the first character is E, or the last character is E, it can be only followed by A here. This is one rule where we are ending with A. Other rule is I, because I also, it has got only, it cannot be followed by an I, it can be followed by an A. So after E and I, there are two cases or the two rules after which we will get the last character as A. And the third rule which says that is U. U can be only followed by A, right? So these are the three, this rule, and this rule, where we are getting A as the last character or the followed up character. That's why we can see the formula here as 3. Now again, let's go again the same concept again, that what are the rules which ends up with E or followed by an E. We calculate as 2 here by searching the strings here, but let's see the same thing as we have done for A. So we see that each vowel A can be only followed by an E. So this is like one case. And again, for I also, it can be followed by an E. So that's why there are 2 rules after which we can see the last character as E. And that's why we have got this 2 formula. The answer is 2 here for E. Or we can also write this formula. I mean, I will just write this as a formula here. If I treat this n is equal to 2 as A2, A2 is the count where we have got the last character as A. So we see that it's based on whatever it was there for E, right? If I treat as E1, which is the count of E1, E1 is that the previous, this portion, this called as, I will mark it as E1, and N2 is like A2. Okay, so it would be for E1, whatever the characters we have got ending with E first, and then E1 plus again I1, because after I also we can have A, and the third one is U1, right? Because after U also we can have this. So this, again, let me reiterate this formula, that we are calculating the number of possible strings which ends with A, but we have also seen that the A can be ended up only when it is prefixed by E, I, or U based on the rules given here. And so one is the one n is equal to n minus 1, whatever is the previous column, we can say. For n is equal to 3, it would be like A3 is equal to E2 plus I2 plus U2, right? So the formula would be just keep on shifting. So this is a formula for, say, A. Similarly, we can do it for E. So E2 can be, E can be followed by an A, here. It would be A1 plus I1, right? Then let's go for I. So I can be here after E. So again, let me write the same formula. I2 would be, I is coming after E, so it would be E1 plus, we cannot follow this, and O after O. So it would be O of 1, right? So that's why it would be 2 again. Now for O2, we see that there is no rules, but except for I, only I can be followed by O2. So it would be I2. And it means that it would be 1. Similarly, the last one, U2. Let's see where we are following with U. So it's I and O, right? Because after this, okay. So it would be I2 plus U2. It would be 2. And if you count all this, the sum would be 10. So this is how we have deduced a formula based on the subdomain problem or the previous problem that we have already calculated. So again, the same formula will go with n is equal to 3 and so on. So for n is equal to 3, just for an example, it would be, the formula would take, I will just convert this as A3 is equal to E2 plus I2 plus U2. So let's see. So for n is equal to 3, it would become 2 plus I1 is 2 again, plus U1 is again 2. So it would be 6. Similarly, A1 plus, for E3, it would be A2 plus I2. A2 plus I2 is 5. For I2, it would be, for I3, it would be E2 plus O2. E2 plus O2 is 3. Similarly, for O, it would be same as I, it would be 3. O2, yes, sorry, it would be 2, right? O2 is I2, O3 would be I2, so I2 is 2 here, it would be 2. And similarly for U3, it would be I2 plus, oh, I have the wrong formulas here, sorry. So yes, I've just, okay. So the formula would be like this, okay. And again, for U3, it would be I2 plus U2. I2 is 2 and 2 is 4. And if you just calculate all this, the 6, and this would be the total sum of this would be our 14 is the sum. So this would be our final, like for n is equal to 3. I think it should be more than 14. I think the formula is not coming correct. Anyway, so you got this just right. I mean, right now we started with our base approach, n is equal to 1, and then we try to see that. First of all, we saw that what is the pattern that we can follow here, and reuse the problem, and we came up with this formula. And finally, the same formula can be applied for further cases for n is equal to 3 and higher numbers. So guys, this was all about the bottom-up dynamic programming approach. We will solve this exactly the same approach that we have developed here, the formula that we have developed here, in our next video in Java and submit in LeetCode. So see you all in the next video.